Hey guys, so today we're going to look about crossing over. Have you ever wondered why people look so different? I mean, really, think about it. Some of us look very similar to our mom or dad, but a lot of us, myself included, have traits that are similar to them, but not exactly the same. This has to do with meiosis, and a special part of meiosis called crossing over. Today we're going to look at how crossing over leads to an amazing amount of diversity. And it also is an indication of just how lucky you are that you were actually formed, as the odds of getting another you are next to impossible. Let's take a look at some background first. Crossing over. What is crossing over? Occurs in prophase 1 of meiosis, leads to an amazing amount of diversity. Remember, in prophase 1, the chromosomes line up next to each other. But why do certain chromosomes line up to similar looking chromosomes? That we're going to see next. How does crossing over work? First, during prophase, one homologous chromosomes line up over the other. In prophase 1, we see that chromosomes that are exactly alike line up next to each other. The chromosome from mom lines up next to the chromosome from dad. These are called homologous chromosomes. Homologous chromosomes are chromosomes that code for the same thing. Homologous chromosomes are chromosomes that are exactly alike or code for the same thing. For example, one chromosome that codes for eye color from mom and the other one that codes for eye color from dad. Because they both code for eye color, we would call them homologous. Example, the chromosome for eye color from your mom is a homologous chromosome for eye color from your dad. Because you have homologous chromosomes, this allows you to get a nice little blending of traits, having one from mom and one from dad, and thus ensuring that traits will be passed on. Then, the homologous chromosome's leg will wrap over each other. In the next step of meiosis, the homologous chromosome's legs will intertwine. This is because they're about to swap. The legs will then break and swap places. Instead of a chromosome from mom and dad, you now have a chromosome with a little bit of mom and a little bit of dad. Due to this swapping, you now have chromosomes that are not exactly alike. Where they swap is completely random. So, how much of mom and how much of dad are going to go into each chromosome is completely random, hence the blending. These combinations are then divided out in meiosis to different sperm and egg. This is completely random. After crossing over, the rest of the steps of meiosis continue. Which chromosome goes to which sperm and which egg is completely random. So really, if you really wanted to get freaked out by this, think of the sheer odds. 1, you don't get to pick where the swap is going to occur in the DNA. Could be a lot, could be a little. 2, this happens in all 23 chromosomes. So let's assume that it happens a little bit into it. The odds that you will get the exact combination are 23 squared. Then take it into the fact that male produces 100,000 sperm, a female 2 million eggs. The odds of that occurring are once again astronomical. Then that one sperm fertilizing with that one egg combining. Hence, why you are incredibly lucky for what you are. The odds are next to impossible. There will never be another you, no matter how hard you try. I'll go into more detail about it later tomorrow. Have a good one, guys, and I'll see you tomorrow.